Hey everyone, in this video we'll continue to look into Agam Robotics, product range, overview, tech specifications, features, functionality, and how to set it up with our Agam Autopilot, which we have seen in the previous episode. So first let's get started with AgamPDB. AgamPDB or Agam Power Distribution Board comes in two variants, one with XT30 pre-soldered and one without. You can choose based on your setup. It's a simple product which uses a power distribution board to power the motors through ESCs or any other peripherals, let's say like video transmitters and so on. And both of these modules currently can do up to like 60 amps continuous and a burst of like 90 to 100 amps depending on your application. And we are working on slightly bigger power distribution boards for bigger applications. So now let's look into power module. Power module in general is a battery monitoring system and not a battery management system, which is like BMS. Here in this case, the power module can only monitor the entire voltage of the battery and not individual cells, and you'll get a complete voltage of the battery and the percentage, and you'll be able to measure like what is the consumption of the battery itself, and in some of the variants we'll be able to get temperature as well. So this is a AgamDPM, which is digital power module. As of now, like all Agam Autopilot comes with like digital power module only, and there is another variant called analog power module which we are not making it, and we'll look into that as well. DPM01 is the first variant, which is a small form factor, low profile design. This version is a 2s to 6s, which means it can do 2 cell to 6 cell batteries. You'll be able to get like voltages and as I said, what is the battery percentage and temperature and so on. And this comes with XT30 pre-soldered with predefined length, and this is by default part of the Agam Autopilot kit. And along with this you'll be getting the cables which we have seen in the first episode. And the other variant is DPM01 12s, which can take from 2 cells to 12 cell, and comes with XT90 pre-soldered, and this also the same features and functionality as DPM01 6s. This will also be able to provide you the current and voltage measurement, and you'll be able to see the battery voltage, overall battery voltage, and you'll be able to like measure the temperature as well in this 12s version. And then we have DPM02. DPM02 is the same DPM01 power module which has been integrated into the power distribution board, which we have seen here. And this integrates in this way, like if you will be able to connect it, DPM02 is the integrated version of power distribution board and power module together. So this reduces the failure points with your connectors and multiple wires. And this has like completely integrated with one wire and pre-soldered with the XT90 connector. You'll be able to directly plug your battery, and this will also power all your motors, and at the same time also power the autopilot through this Molex connector. And this will also give you the same features and functionality as power module, which is DPM01. And this actually reduces the weight and space in your system. One disadvantage, or I would say like one disadvantage with this is you'll be able to only do a quadcopter configuration or lower, because it has like 5 number of connectors. You'll be able to do like, let's say 4 quadcopter and 1 for your peripherals. It could be anything, video transmission systems or server, whatever it is. So in that case, like you can't do anything above quadcopter if you want to do hexacopter or anything with this system. So again, Agam Robotics is working on those kind of products, and we are working on building like larger DPMs for bigger applications. That's going to be happening in this year, so stay tuned for that. And I also want to note here that like Agam Autopilot is one of the few autopilots which can support both analog and digital power module. So analog is directly going to output voltage and current sense in the ranges of like, let's say 0 to 3.3 volts, and we have a custom cable where you can get autopilot working with that as well. So this setup of analog and digital we'll look into the other later part of the episodes. For now, we'll only cover what we are making at Agam Robotics. So now let's integrate this power module into the drone and see how we can set it up. So I'll bring the drone what we had last time here, and we'll connect the USB cable to the Q ground control and integrate it. So in this drone, as you can see, I'll put the products outside here so you can visibly see it. And we already have a power module connected to the autopilot and also hooked to the power distribution board inside the drone. And we have the battery on the bottom of the drone. So once we connect this and get the power module show up here, for that, what we have to do, as you can see here, is there is no battery indication yet. So once we connect the batteries, you will be able to do it. But before that, I'll show you the parameters what you need to check. So by default, on our autopilot version 1.16.0 and above, you don't have to do any parameter setup. The autopilot or the PX4 firmware will automatically detect the power module based on what you are plugging in. But you have to make sure those parameters are disabled. So there is a chip called INA228. So you need to search for INA. And as you can see here, there is 226, 228, 238. 226 is for 6S version and 228 is for 12S version. Just make sure these two are disabled. In that way, the PX4 will automatically detect what is being used. If you enable 226 and plug 228, it may not detect, or the other way around, it may not detect. So make sure you have disabled this and you're good to go. And another thing you need to do is the power tab. Go to the power tab and set up the number of cells, the total input voltage per cell, not the total battery voltage, just individual cells, and then the full voltage of individual cell. So this will give you the total of the min and max of the battery. And you don't have to do anything with the voltage divider or amps per volt. These are for analog systems. So since this is digital, you can completely ignore that. And PX4 will automatically detect and calculate these values for you. And now once you plug in the battery, you will get the battery voltages. As you can see here, there is a percentage, the total battery voltage and the power consumption. And in the 12S version, you will also get the temperature of the power module. This is not for the autopilot, this is of the power module. So this is how easy of setup you can do with the AgamDPM 01 or 02. Alright, so now let's look into the next product. Now let's look into the next product, which is FloRange sensor. So this sensor is an integration of optical flow sensor and range finder, which uses time of flight sensor. So it's together called FloRange sensor. This sensor allows your drone to hold position locally, meaning it can be used where GPS is denied or in cases of flying indoors, or in case where you want to aid GPS and the drone is moving from outdoors to indoors and you suddenly lose satellites of near GPS, then you will be able to get this sensor to hold the position locally. And this is an integrated module which uses DroneCAN protocol. Without going too much in depth, DroneCAN is an open software communication protocol for flight controllers and other CAN devices to communicate with each other without having to send raw data sensor data to the autopilot. This process and gives the data which is required by the autopilot, and it will be used for it could be for position holding or processing the sensor data. So this module, even though it is a small tiny device, it has its own microcontroller and has an IR LED to do low light conditions for the optical flow sensor, and also has an IMU to integrate the sensor data and provides that process data to the autopilot. So this is a very tiny form factor device which can help you in position holding on your drone, or like in cases of where you want to use this for takeoff and landing applications, you'll be able to use this for doing a precise landing. It can do centimeter level precision landing, and also supports QR codes and other code readers. You'll be able to get precise landing through that. So now let's look into how to integrate this with our Agam Autopilot. So for that you need a 4-pin CAN cable. So as you can see here, we have a longer cable as well as short cable. So this comes with flow sensor and GNSS. And before plugging it in, make sure the wires are twisted. So the reason why you had to do this is it cancels out the electromagnetic interference coming from the cable, and it also reduces the crosstalk within the system, and also it allows you to do a proper and clean wire harness in your drone setup. So just plug this in once you're done with that, and this gets into the 4-pin CAN connector on the autopilot. As you can see, it's there on the right side. So I'll just plug this in, and this needs to be pointed forward. The logo what you see here on the Agam logo, that is pointing forward, and this needs to be facing downwards. So this has to be mounted like this under the drone, so that this has a very clear view of the ground, and there are no obstructions from the drone, let's say wires or cables or something. Just make sure this visibility is clear from the sensor, and this has to be mounted like this, pointing forward and facing downwards. So now we'll just leave it here for now, and let's see how to connect the flow sensor to the QGC and set it up. So I'll plug in the USB cable to the autopilot, and wait for it to detect. There are some parameters which are already set here for the sensors on this drone. So I'll just walk you through all the parameters that are needed. So once you're into the vehicle configuration, navigate to the parameters. Here you need to search for UAV CAN. So here in this case it's already set. So as you can see, all the parameters for UAV CAN is showing up. But if it is not enabled, typically you'll see only this UAV CAN enable in the disabled option. So just go to the drop down and select sensor automatic config. This automatically sets node IDs for any of the CAN devices in the system. And once this is done, you need to save and click reboot. So go to tools and do a reboot. Once you do that and come back to the same parameters tab and search for UAV CAN, you'll start seeing so many of these parameters. So once you are done with that, you need to select UAV CAN underscore sub. So here, as you can see, UAV CAN, you need to enable sub flow. If it is disabled, you need to enable this, and then you also need to enable sub RNG, which is the rangefinder. As you know, in the optical flow range sensor, we have flow sensor as well as rangefinder. So we are going to enable these two sensors, and once you are done with that, you need to save and reboot. And once you do that, you can start setting up your sensor operations. So now you need to enable how to integrate these sensors into the autopilot. How can we utilize these sensor data by the autopilot? So for that, you need to search EKF2, which is our Kalman filter process, which is the algorithm to integrate a lot of sensors like IMU, barometer, magnetometer. Now we need to put these sensors also into that, so it does the complete sensor fusion and allows you to hold that drone in a stable process. So search for EKF2, and then you need to search underscore OF for optical flow sensor control. If this is disabled, by default you need to enable this. So which means this allows you to do that optical flow aiding. So once this is done, you can search for EKF2 RNG, and if this is also not enabled, you need to select enable conditional mode. So once you do this and save it, you're going to be integrating the sensor data into the autopilot. And if you want to completely eliminate using GPS, and you want to use just the flow sensor for GPS denied environments or indoor testing, you can actually go to EKF2 GPS, and you can disable the complete GPS control as well. Or if you have the GPS and you want to integrate the GPS, which we have here, I'll show you that as well. So we'll be able to integrate the GPS and use the optical flow sensor as an aid to the GPS. So you can leave this option as it is in that case. And now once you are done with this, you have to set the min and max of the sensors now. So now we'll go to search UAV CAN RNG min and max. Minimum is 0.08. If it is not set to any values or it is like slightly higher, the default is set to 0. So you need to set this to 0.08 mm, which is where the minimum distance the rangefinder can measure. And the max value, set it to 30 meters if it is not. And based on your environment, you can start increasing this value and test it up to 50, 60, 80 meters. The sensor itself can do up to 100 meter. Do not go beyond that because it may have like a very low precision in terms of holding the drone position. So I would recommend setting it to 30 and then keep increasing every 10 meters and test it out in your current environment. And once you feel like it is good at certain height, let's say 70, 80 meters, you can lock it to that. And once you have done the min and max of the range finder, now we can do it with flow sensor. So now you have to search sense flow. The max height you need to set it to 30 meters here, and then as I said, the same way with both rangefinder and optical flow, you need to keep increasing this and test it out in your environment. And then the flow max R value needs to be set to 7.4. I think it will be typically 8, so you need to set it to 7.4. This is for the flow sensor again. And once these two are done, you can go to sense EKF2 RNG Q quality. So this is the how good the quality data it is passing through. So it needs to be 0.2 seconds. And once this is set, you need to position the sensor on the drone. So the sensor can be mounted anywhere on the frame. But you will need to specify once this is set, you need to position the sensor on the drone. You can place the sensor anywhere in the system, but you need to specify what distance it is from the center of gravity. So if you are placing this sensor on the front of the frame, you need to give this value of how far it is from the center of gravity in X, Y and Z. And this you need to define or specify for both the sensors. So now you need to go to the parameter EKF2. Let's do for optical flow first. And as you can see here, there is position X, position Y and position Z. So you need to set in each direction of X, Y and Z, and you need to give those values. So if it is at the center you are placing it, then you can leave X and Y 0 and just define the height where it is downwards, which means like let's say it is 10 centimeters down the place where I'm mounting the sensors, like it will be right below the battery, and I need to set this value to 0.1. And the same way you need to do it for RNG, which is rangefinder. And you can see the same parameters, position X, Y and Z. And I'll also define this as 0.1. So now we have defined where the sensor is going to be positioned. So this is all set for the optical flow sensor. But how do we test before we fly that this is working? So now we can go over to the Analyze tool, Mavlink Inspector. You should be able to see two sensors data being sent here on Mavlink. So one is the distance sensor. As you can see, this is the distance measured from the rangefinder. So now it is 0, and as I move, you can see that it is measuring the distance, and the current distance keep varying. And this is for the distance sensor. And for the optical flow, there is optical flow RAT. This, if you see, it always tries to make the integrated X and Y data to be 0 all the time. So if I'm positioning downwards, you can see these two data points are always 0. And if I move it, it reads the data and then tries to make it 0 all the time. So this is how it is going to be positioning. These are the three data, which is X, Y, and your Z from the distance sensor is being sent to the autopilot to make that holding position. And the EKF2, whatever the parameters we set, is the algorithm which is going to use this data and fuse it with the IMU, magnetometer and barometer on the autopilot and use this to hold that position.